Hello everyone, I'm Moshir Rahman, and today the topic for this video is component diagram. So we'll be looking at what component diagrams are, what elements are there in a component diagram, and finally we will look at some use cases and some examples of component diagram. So what actually is component diagram? The component diagram is a type of UML diagram which actually describes the dependencies between each software components. So by software component we actually mean different parts of a software which can act individually or which perform a specific set of functionalities within the system. It is also we also use it to model the physical implementation of a software. It's also used to model the high-level software components and their interfaces. So basically, we design how the software components interact with each other through their interfaces within a system. All these representations are shown in a component diagram. We also get the static implementation view of a full software system through these component diagrams. And finally, component diagram is a type of UML diagram which is a structural UML diagram. So it actually falls under structural UML diagram type. Okay. So a component is basically a modular unit within a system, and it has some well-defined interfaces. So by interfaces we actually mean it's providing some functionalities to its environment, and it's providing those functionalities through its interfaces. And each of these components are autonomous unit within a system, and it has one or more provided and required interface. So provided and required interfaces are two types of interface, and we will cover that later. And its internals are encapsulated, hidden, and inaccessible. So it basically means that where the internal implementation of each components are hidden from the user. So component basically acts as a black box, and it acts as a black box so that we don't need to worry about the internal implementation. We only worry about each components and their functionalities provided. And its dependencies are designed such that it can be treated as independently as possible. So we design each component in such a way that that each of these component can be replaceable, and whenever we replace this component, it's not going to require us to change the whole system or whole software. That's how each of these components are designed. And the components can be a database, a user interface, or a hardware component such as circuit, microchip, or device, or a business unit such as supplier, payroll, or shipping. So it can be anything. It can be anything within a system can be a software component. So it doesn't need to be only some pieces of code, but it can also be chip, circuit, device, user interface, database, or even business units like supplier, payroll, or shipping. So any of this can be treated as a component. Okay, now let's look at some component notation, how we represent each component within a system. So in the first type of notation, there is a rectangular box, and within the rectangular box there is a stereotype, and this is called a stereotype when we write something within two angle brackets, and underneath that there is the name of the component. So there is the first type of notation. The second type of notation, there is a component icon and the name of the component, and in the third type of notation there is the component stereotype and the component icon. So stereotypes are basically the stereotype basically represents the type of component we are talking about, and there can be each component can be labeled with multiple stereotypes. So other types of stereotypes are entity, subsystem, table, library. All these are different types of different stereotypes. Okay, so we can use them alternatively, or you can use multiple stereotypes within a component to describe the type of the component. Now let's look at the component elements. So there are mainly four elements of a component, and these four elements are interfaces, usage dependencies, ports, and connectors. So interfaces basically represents a set of operation and obligations. Usage dependency shows the relationship in which one element requires another element. Ports represent interaction point, and connectors represent the connection between two components through interface. So we'll be looking at each of these elements in detail in the next slides. Interface defines the behavior of a component. It defines what functionalities a component can provide or what functionalities it may require from other components. So it's basically a set or collection of operations that it can provide to its environment or it may require, and the implementation is normally provided by another class or component or the component itself, because in the interface there is actually no implementation going on within the interface itself, but the implementation actually happens within the component or another components. So in complex system, this implementation may be provided by multiple components rather than a single one. So there are mainly two types of interface. One is provided interface, another is required interface. The provided interface basically defines what services the component or what functionalities the component can provide to its environment, and it has a ball notation, and it is labeled with a name on top of it. So for example, this order component can provide order entry related functionalities and account payable related functionalities to its environment, which other components can use. And for required interface, by required interface, the component actually defines what type of services or functionalities it needs from another component. So it is defined by it is labeled with a name and has a socket notation, this bracket like notation, and the interface that it requires is labeled on top of it as well. So when two components or classes provide and require the same interface, then these two notations are combined. So basically when one component is providing an interface that another component requires, then they are combined together, and the label or the name of the interface is written on top, just to mean that they are providing and requiring the same interface. In a system where there are multiple components, we represent like this. Here we can see that there are multiple components on the right side, which is providing the same interface that is required by the manager component, and the manager component will decide which component to receive the implementation or the functionalities from during the execution or the runtime. So it is defined during the runtime. Now let's look at usage dependency. Usage dependency is basically a relationship where one element may require another element for its full implementation. So it's basically when we import a package or a library within our code. That's how we represent the usage dependency, or that's what the usage dependency represents. That a piece of code or a part of a system or a component or a package may require another package, and in that case we use this type of dependency, and the notation is given by this dashed arrow, and there is a label on top of it, what type of or what relationship it is, and that's how it works. And over here, as this is showing, a web shopping package uses a payment package. So basically when we are using some external APIs or libraries or payment gateways or anything like that, that's those type of dependencies are shown by usage dependency element, or by usage dependency notation. Next, next a port basically defines a distinct interaction point. So through a port, the internal component or a component can communicate or delegate its functionalities to its environment, or an external component can provide some functionalities to its to some internal components. So port basically is a gateway for internal components and external components, for each of them to communicate with each other. Ports may have visibility. When it's drawn over the boundary of a component, it means that the port is public, and also means that all the interfaces that are connected to that port are also public. And when it is drawn inside the component, then it is either protected or private. So this is an example or a figure where we can see the implementation of a port. So here is a port. The notation of a port is given by a rectangle on top of the component boundary. It may be here or it may be inside as well. And through this port we can see that there are some internal components. For example, this safety inspection component is providing its state interface, or it's providing a state interface, and this provided interface is being delegated, or it's being passed on to its external environment through this port. And that's how the state interface is being exposed to the external environment for external components to use this interface. So similarly, it can also expose some required interface as well through the means of a port. Now let's look at connectors. Connectors may be two types. One is assembly connector, another is delegation connector. Assembly connector is, we have already looked at it. Assembly connectors are basically the ball socket notation, where an interface requires and another interface provides the same and a component requires and another component provides the same interface, and they're joined together to form through an assembly connector. So this is an assembly connector, and this is a ball socket. This connection is called a ball socket connection. And for delegation connector, okay, before that, let us look at, in case of multiple connections, well, this is how multiple connections are represented. There are multiple components, and each of them provide a certain interface which another component uses. So that's how multiple components actually provide or require same type of interface. And for delegation connector, this is how an interface is exposed to its external environment through the port. So basically, through the connector actually forwards the signal from the internal component to the external one through a port. So this is the port, and this line, the line through which the interface is connected, this is a delegation connector. So basically, delegation connector exposes the internal interfaces of a internal component to the external environment. So that's how it works, and it must only be defined between used interfaces or ports of the same kind. So basically, whenever this connector connects two interfaces, then the interfaces must be the same. For example, the safety inspection provides a state interface, which is then connected through a delegator connector and is exposed to the environment, and the external interface that is exposed, that is also the state interface. So it cannot be something different, like one is state, another cannot be something other than state. So they must be the same when it is connected through a delegation connector. Next, we have dependency relation. So we have already covered four main types of element, and this is another type of relationship that may exist in a component diagram. So in this type of relation, it's basically showing that a component is dependent on another component based on data from another component. So For example, over here the customer component is dependent on online shopping component on data from the online shopping component. So online shopping component, or it is a database, and from this it's passing on data to the customer component, the order component, and these two component depends on the data from this component. So in such cases we use this dependency relation, and it is different because this is not something like we are importing anything, or we are connecting to external library or something like that. It's just we are requiring data from another component. That's why they are connected to this relationship.